Hello and welcome to my channel. Today I'm inviting you to decode Earth's timeline. Being precise, to decode and analyze International Chronostratigraphic Chart published on the website of International Commission on Stratigraphy. This is the latest version. First of all, we need to understand names of columns in this chart. For example, eonotem, eon, eratem, era, system and period, series and epoch, stage and age. So why are they doubled? That's the first task for us. We also need to understand the meaning of GSSP, how numerical age is presented, and what is GSSA. So let's start why the names of columns are doubled. Because this chart describes units in stratigraphy and chronology. Stratigraphy is a study of stratification. In other words, study of layering. Stratification, rock layers. Rock layers, also the term strata is used. The term strata comes from Latin and it's a plural of stratum, mean layers. So strata, layers, stratum, layer. Chronostratigraphy is a subfield of stratigraphy, so the study of rock layers by time relation. And the name comes from Greek, when chronos means time. Chronostratigraphic units describe geological material, a layer, a physical rock layer. Chronology is a study of measuring time by regular division and locating events in time. Comes from two Greek words, chronos, you know the words used, yet time, and logia, words that can be translated as describing of time. And geochronology determines the order or events in the history of the Earth with numerical dating. So geochronology units describe time divisions. Let's compare the names of columns in chronostratigraphy and geochronology. Chronostratigraphy use the term eonotem, geochronology, eon. The enotem and eon is the largest category. Next one is eratem in chronostratigraphy or era in geochronology. System and period, series and epoch, stage and age. Names for chronostratigraphy and geochronology units are the same. For example, Phanerozoic is a eonotem and eon. Cenozoic, eratem or era. Quaternary, system or period. Holocene, series or epoch. Megalian, stage or age. By the way, Megalian is the time when we live now. But the terms upper, middle, and lower describes material and are used by chronostratigraphy. Late, middle, and early describe times. So that's used by geochronology. For example, Tiktaalik fossils were found in the Upper Devonian series. Tiktaalik lived during the late Devonian epoch. So what's the difference? Tiktaalik fossils were found, so we are talking about physical fossils that were found in physical layer of rock in the Upper Devonian series. So the rocks come from the Upper Devonian series. But Tiktaalik lived during the late Devonian epoch because we are talking about time. By the way, this nice creature creature fossils were found on Ellesmere Island in Canada. Another example, the best coal is extracted from the Carboniferous system. And again, we are using chronostratigraphy term because we are describing rocks. The richest coal deposit come from the Carboniferous period because we are talking about time. Another one. Only seed ferns and gymnosperms were found in the Middle Triassic series. So again, we are talking about physical layer. There were no flowering plants in the Middle Triassic epoch because we're describing the time. And please remember, this chart is not in a linear scale. This small box represents 4 billion years. In other words, 4,000 million years. The big one, only 500 million years. Why? More divisions mean more information. So the younger strata is, the more detailed information is saved. So this is a comparison to more or less linear scale. This gives you an idea of a proportion of 4 billion years to roughly 500 million years. The age in the chart is given in million of years. Sometimes million of years is described by MA, what means mega annum. Annum in Latin means year. Because the main unit is given in millions of years, that's why we have thousands of millions and fraction of million. The fraction of million means thousand of years and sometimes is used as kiloannum. The thousands of millions means billions of years and sometimes is called gigaannum. And on my linear scale, you can see that the age is given in gigaannum. Now we are going to decode names presented in rows in the International Chronostratigraphic Chart. Knowing etymology of the names helps to remember them, but also what's more important, gives a big picture what happened in the Earth history. So we will start from Ionotem or Ion names. Hadean, the first unit. The name comes from the name of Hades, a god of underworld in the Greek mythology. Why such reference? During Hadean, Earth was formed by accretion of material from protoplanetary disk. The heat emitted in the process led to melting the entire planet, providing condition for differentiation process that shaped the Earth's core, mantle, and crust, actually protocrust in Hadean. Moon was created as a result of a massive collision with Theia, a Mars-sized object. Atmosphere was thick, mostly consisting of methane and ammonia and other greenhouse gases, including water vapor. And at the end of the Hadean, water existed in a liquid form, although temperature was still high, but the high pressure caused that was possible. The Earth surface represented very hellish condition, as you can see in this picture. Next unit, Archean. The name Archean comes from two Greek words meaning ancient and beginning, and the words refer to the first noticeable form of life on our planet, represented by bacteria and archaea. Oh, by the way, archaea, you can connect archaea and archean to memorize the name of this unit. This artistic image presents stromatolites in the foreground. Stromatolites are a symbol of Archean. They are made of cyanobacteria mud and environmental sediments. Cyanobacteria played a very important role in the Earth history because cyanobacteria was the first organism uh, that could photosynthesize and producing O2. And the O2 production shaped what happened in the next unit, Proterozoic. Proterozoic comes from the words proteros means previous or early in Greek, and zois, life. And the accumulation of O2, of molecular oxygen, shaped significant changes in in the planet atmosphere. The changes in atmosphere caused by the rise of oxygen led to concentration and accumulation of oxygen in the atmosphere, and the accumulation of O2 caused elimination of greenhouses, especially methane, very effective greenhouse gas. And that led to global glaciation. It's known as snowball Earth or slush ball Earth. But also Proterozoic is known for its development of first eukaryotic life and first more complex life at the end of Proterozoic. The next unit, Phanerozoic, comes from the Greek words meaning visible life. And it is characterized by the proliferation of diverse and abundant life forms. Also, the term Precambrian is used in this chart. This term is not official. You can see it's given in italic in this chart. It is used to describe first three eratems, ionotem or eons, Hadean, Archean, and Proterozoic. And the term Precambrian means that pre is used for the before. No, but Cambrian is the first subdivision of Paleozoic era or eratem in Phanerozoic, the next eratem, ionotem or eon. Why Precambrian? because Cambrian is connected with so-called Cambrian explosion, so a big diversification of forms of life that had not existed before. And now we are going to analyze the names of era terms or eras. All of them comes from Greek. And eos means dawn and is used to describe the first subdivision of Archean, Eo-Archean. Paleo comes from the Greek words meaning old, and it used to describe Paleoarchean, also Paleoproterozoic and Paleozoic. The word meso means middle in Greek. And if you look at this graph, you can see that it's in the middle. So the eratem or era are located in the middle. So we have Mesoarchean, Mesoproterozoic, and Mesozoic. And neo means new. So we have Neo-Archean and Neoproterozoic. And if you look at this name, Cenozoic, also comes from the word meaning new, but a little bit different one, but in the same meaning. So that's why we have Cenozoic eratem or era. Now we are going to analyze names of system or periods. The word Siderian comes from Greek term sideros, meaning iron. Siderian marked the peak deposition of banded iron formation. The deposition was possible thanks to O2 produced by cyanobacteria in Archean and O2 reaction with iron dissolved in the ocean. So the Siderian period marked a pivotal shift in Earth atmosphere that led to global glaciation that lasted until 2.1 billion years ago. And at the end of Triassian, next unit that comes from the Greek word stream refers to stream of lava, reflecting the significant volcanic activity and tectonic shifts. And those shifts, if we are looking at this map presenting land masses around 2 billion years ago and land masses around 1.8 billion years ago, we can notice that the land masses that were scattered about around the world about 2 billion years ago, then began to create one land masses, one super continent, squeezing ocean sediments between them, creating origins, in other words, mountain range. So the name of the next unit, Orosirian, comes from the Greek word meaning mountain range. The next unit, Staterian, that means stable in Greek, refers to the pretty stable condition leading to creating Nuna supercontinent, also known as Columbia supercontinent. continent. So Straterian reflects relatively steady tectonic and environmental conditions. Going further to Mesoproterozoic and analyzing names of system or periods, we have Kalymnian, Ectasian, and Stenian. The name Kalymnian comes from the Greek word meaning cover, and it's connected to expansion of platform covers, so the layers of rock that formed over older cratons. And the next unit, Ectasian, comes from the word extension, and it's connected to still lasting expansion of the platform covers, but also connected to breakup of the supercontinent. And the breakup of the supercontinent finally led to creating the new one, supercontinent, in the next unit, Stenia. The name is derived from the Greek word meaning narrow and reflects the narrow so-called polymetamorphic belts that was created at that time. Going further, we are in Neoproterozoic, and the name Tonian is derived from the Greek word meaning stretch. And the word stretch reflects the geological activity of rifting that led to the breakup of the supercontinent that existed at that time. The next unit, cryogenian, comes from two Greek words meaning cold and genesis or birth. So what can be translated as a birth of cold. And it's connected to snowball earth or slushball earth, generally speaking, global glaciation. The next unit, Ediacaran, the name comes from, not from Greek, I'm very sorry, comes from Ediacara Hills in Australia, where Ediacaran biota fossils were found. Going further, we are crossing the border of Precambrian, and we are in Paleozoic era, or eratem, of Phanerozoic eon or eonotem, and analyzing the names of system or periods, we start from Cambrian. Cambrian, the names derives from Cambria, the Roman name for Wales, where rocks from the period were first studied. Ordovician Its name came from Ordovices, an ancient Welsh tribe, reflecting the period's discovery in rocks from Wales. The Silurian period or system, its name comes from the Silurs, an ancient Welsh tribe reflecting the periods of discovery of the rocks. Devonian. Its name comes from Devon, a region in southwestern England where rocks from this period were first studied. Carboniferous is named derived from the Latin word for coal bearing and reflects the extensive formation of coal deposits during the time. Permian, its name comes from the Perm region in Russia, where rocks from this period were first studied. Triassic, Jurassic, and Cretaceous are subdivision of Mesozoic era or Eratem. Triassic, its names come from the Latin word for triada or threefold, reflecting the division of rocks, typical rocks like sandstone, limestone, and clay, reflecting the distinct three layers. Jurassic, its name comes from the Jura Mountains located on the border of France and Switzerland. Also, it can be connected with Celtic words meaning wooded mountain. And the Cretaceous, its name comes from the Latin word creta, meaning chalk, but also can be connected with the place terrain Cretas in Paris Basin. And Paleogen and Neogen, so the first subdivision of Cenozoic era or Eratem. Paleogen and Neogen, the names come from Greek and can be translated as old and newborn. And old born reflects the emergence of many modern life forms after the extinction of non-avian dinosaurs at the end of Mesozoic. And Neogen, emphasizing the emergence of modern marine and terrestrial fossils during that time. Quaternary, its name it's derived from Latin word for fourth, reflects its position as the fourth major division of Earth's geologic history, borrowed from Jules Desnoyers, French scientist, that divided the Earth's history in four eras. That were his eras: primary, secondary, tertiary, and quaternary. I will skip the names, etymology of the names of series or epochs and stages or ages for now. We'll come back at the end of this video and you will see why. Now we are going to the next column in the ICC chart, GSSP. So GSSP is a global boundary stratotype, sectioned and point. Boundary stratotype is the specified sequence of strata that contains the specific point that defines a boundary between two stratigraphic units. So it's an exposure of a boundary between layers that is used as a standard reference. and reference point on stratigraphic section of rock, which define the lower boundaries of stages. So remember, of stages on the International Chronostratigraphic Chart. And the boundary is defined by a spike in a rock succession, coincident with available biological and other markers. And since 1977, the ICS has maintained the international GSSP register. Golden spike. You saw in the chart that there is golden spike. So the golden spike boundary stratotype is marked at the point preferably by a permanent artificial marker in the field. So in the chart, you have a golden spike, the icon of a golden spike. In the field, you have physical marker. And what's important, stratotypes must be accessible to all who are interested in their study, regardless of political or other circumstances, and there should be reasonable assurance of their long-term preservation. You can find the map of all GSSP in the world on the website of the ICS stratigraphy.org. And I will not discuss all of GSSP. This video will be endless, but I chose two of GSSP, very unique and very special. First is the GSSP marking the bottom border of Fortunian stage. So it's the first stage of Terranubian series of Cambrian system. So why is this GSSP so special? Because it marks the border between Precambrian, you remember the term Precambrian and Cambrian. So it's the border between two ionothems, Proterozoic and Phanerozoic. And yes, you've heard very well. I'm using in this moment units for chronostratigraphy because we are talking about physical rock layers and the border between them. This GSSP is located near the town of Fortune, so that's why the name Fortunian in southeastern Newfoundland, Canada. Why this GSP is unique? Why is this GSP unique? Because it's the only stratigraphic boundary established on ichnological grounds. Ichnology is the study of the fossilized tracks, trade, bottles, and excavation made by animals. This is the picture of the GSSP in the field, and it was placed at the base of the Treptichnus pedum zone and Harlaniella podolica. So Harlaniella podolica comes from Ediacaran series, Trepticus pedum from Cambrian. The second GSSP I chose for you is a special because it's the only one for now established for the bottom of the border of system, not for stage, and it's located in Enorama Creek section in the Flinders Range of South Australia. And this GSSP, you can see in this picture, it's pretty well marked. It's a close look at the GSSP. And the GSSP level is just below the midpoint of the fourth paleomagnetic drill hole from the bottom, where carbonate cemented siltstone is overlined by sheet cracked carbonate. And next, GSSA. GSSA is a global standard stratigraphic ages. It's used to describe the base of units prior Cryogenian. So generally speaking, Precambrian is divided into units based on GSSA, besides Ediacaran that has GSSP, and also for Cryogenian GSSP is pending. It means that it's not ratifying at this moment. But look at the in the chart, you can see the icon of a clock, I think. It means that the bottom of this unit is based on GSSA. And looking for GSSA, I would like to present you a very special one. If you look at the numbers, you can see they are pretty even, right? Right? Right. But here you go. You have 4,031 plus minus 3 million years. Why? How do we know so precise number? Because of Acasta Gneiss complex in the Northwestern Territories in Canada. And generally, some information about gneiss. It's a type of metamorphic rock and has a distinct banded or foliated appearance, forms under high temperature and pressure conditions, which cause that minerals with the rock to recrystallize and align in layers, and these layers often alternate between light and dark minerals and has a characteristic look. And Acasta complex. Why is Acasta Gneiss complex so important? Because of its age. It is the oldest rock on our planet. 4.031 billion years plus minus 3 millions. And also because it's nice and it's a metamorphic granite that gives us information about a continental crust that existed at that time. The granite age is estimated around 4.31 billion years. And going further to the bottom border of Hadean, you can see again so precise data, 4.567 billion years. How do we know about it? I just told you that the oldest rock on Earth is 4.031 billion years. So we need to back in time to the early stage of our planet creation from protoplanetary disk. First, calcium and aluminum particles, condensate, and chondrules appeared. Next, they accreted into planetissimos and planetary embryos, and finally protoplanets. But some of them are still in space, and sometimes they hit our planets. So the oldest meteorites that hit Earth are Allende in Mexico and Efremovka in Kazakhstan, and their age is estimated for 4.567 billion years. So no rocks survived from Hadean, but we have information from extraterrestrial bodies that hit our planet and the extraterrestrial body are remains of the very beginning of a solar system creation. What is also important in study of rocks, I told you that no Hadean rocks survived, but discovery of zircon crystal in Jack Hills in Australia and its age dated on 4.37 billion years. This is the age of the rock that was metamorphized, so not the age of the existing rock. And because it's the age of the rock that was metamorphized, it's interpreted as existing of proto-crust 4.37 billion years ago. And the proto-crust was destroyed by late heavy bombardment and took place at the end of Hadean and the beginning of Archean. And this date, 4.37 billion years, it's a proposition for subdividing Hadean into two divisions, Neo-Hadean and Paleo-Hadean. So knowing information about the names etymology for Neo and Paleo, I'm pretty sure you can understand the terms. Summarizing. This chart is not to scale. Yeah, you remember the big box represents only last roughly 500 million years. This chart represents chronostratigraphy and geochronology units. GSSP marks the bottom border of layers. GSSA, I'd say that marks bottom layer of time. And the main unit for measuring age is given in millions of years. So that's why we have thousands of millions and also fraction of million. Most names come from Greek, but some from tribes, places, and typical rocks. You have some references. There are references that I used for preparing this video. And I promised something extra. So this is a bonus for you. We talked that Hadean, Ion or Ionotem, has no eras or eratems. Archean is divided into eras or eratems, but no periods or systems. Proterozoic is divided into eras or eratems, those into periods or system, but no epochs or series. And the names come mostly from Greek, and one name comes from name of the place. Remember? Jakarta. Phanerozoic has full set of subdivisions. So Phanerozoic Ion or Inotem is divided into eras and eratems. The names comes from Greek. Periods, eras or eratems are divided into periods or respectively system. The names come from tribes, places, or typical rocks. Periods or systems are divided into epochs or series, and the names come from Greek or places. There are also used terms of late, middle, and early, or upper, middle, or lower. And epochs or series are divided into ages or stages respectively. And now there's a task for you. So using the International Commission on Stratigraphy website, try to decode the names of epochs and ages, those that are connected with places, maybe find the geographical location. Also, there are some names with etymology that comes from Greek words. Here you go, you have a hint for the word. And thank you for watching. If you like this video, give me a thumb up and please subscribe. Both actions help me a lot. With geo greetings. See you next time.